Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today I'm going to talk about a very small topic but very interesting one, and it is about concurrent glue jobs. And I have seen one questions many times from my customer, and when you try to answer that question, concept of concurrent jobs comes into the design, and that's what I plan to discuss today, and also have a demo towards the end of the presentation to show how it works. So let's get started. So let's try to solve a problem first. So suppose that you are building a data platform and you have some JDBC endpoint, some relational database from where you want to ingest data to your data platform, say in Amazon S3 bucket. And in your JDBC endpoint, you have got 200 tables, even more than that. Okay, so let's take 200 as examples. You have got customers tables, sales, order, invoices, product line. I mean, yeah, there are 200 tables into your JDBC system, which you want to ingest into your data platform. And you want to ingest that in different folders in your raw in the raw bucket. So in your data platform, you have created a raw data area, and in that raw data area, you are ingesting your data, or you are storing your data in different folders. So customer goes to customers folder, sales goes to sales folder, orders, invoices folder, so on and so forth. So the question is, how do I solve this problem? How should you be writing a glue job which can ingest such a large number of relational data, table data, and store into your data platform in S3 bucket? So there could be multiple approaches to solve this problem. One approach could be, I will run one master glue job which will take care of all 200 tables. So basically I'm talking about, I write one big glue job, which is first ingesting my customers table, then my sales table, then my orders table, then invoices, and so on and so forth. Yeah, so definitely, I mean, it's going to be a very big script. That's a drawback, but then it's also going to be a single job which is taking care of everything. This could be one approach. It works, but it comes with certain key challenges. And the two key challenges I want to highlight is, one, it is a monolithic approach. It's like putting all your eggs into one bucket kind of thing. So you are writing one big glue job which takes care of all the data getting ingested from your JDBC endpoint to S3. It's very hard. Such a script is very hard to maintain. It's a huge script. And think of a scenario where you are running this job, and after, say, orders table getting ingested, when the script went for invoice, suddenly the script failed. And script failed because for short term the database refused the connection, or your database something else went wrong. There's some error in the script, some schema change, I don't know. Anything can happen. But suppose that in between this whole monolithic script, out of 200 tables, 30 tables you have ingested, and on 31st table your script fails. Then running the retry is going to be a really tough job for you, because you have to run those 29, 30 table ingestion again, unless you try to build some kind of business logic to avoid any kind of re-ingestion. So handling the retry and errors is really a challenge when you write such a big, large, monolithic glue job. So yeah, it is an approach. It can work, but not a very good approach from these two key challenges point of view. So what else we can do? We can go totally at the other end, and that is, I will write one glue job per ingestion. So basically I'm going to have one glue job for customers ingestion, one glue job for my sales ingestion, one for order, one for invoices, and so on and so forth for all those 200 tables. That could be another way of doing it. Again, this is going to work. But as I told you, this is the extreme other end, you will see. So one monolithic job was one end, and writing one job per ingestion is other end. And the key challenge you see with such approach is, first of all, it's too many jobs to maintain. We are talking about 200 jobs here, which will be very hard to maintain, hard to go and make changes. The second biggest problem is your job will have a lot of duplicate data. Not that you cannot write a duplicate code. And not that you cannot write a duplicate code, you can write duplicate code, but there should be some way of improving it. And I know that we did another tutorial where you can actually put this duplicate into some external library, and that way you can optimize. So avoid writing duplicate code, but still you have 200 jobs to maintain. And if you have, I don't know, such 5 or 10 databases, then think of how many jobs you have to maintain. So this again is a very good, it's a good working approach, but the biggest challenge is so many jobs to maintain. So what is the middle ground? And the middle ground is the approach number 3. And the approach number 3 is what I'm going to discuss today here. And the approach number 3 is that you create one job but do multiple concurrent runs. So you want to run one, you want to create one job. So code wise you are writing only one job, but this job you can reuse, you can rerun, concurrently rerun for multiple data ingestion. So that way you have a small code to maintain, one job to maintain, but this job is kind of a Swiss knife, which is taking care of data ingestion from all different data tables. So basically we are talking about a parameterized and concurrent glue job, and I will talk about parameterization and concurrency in more detail in the coming slides. But essentially we are talking about a single job which is configured for parameterization, which is configured for concurrent runs. So you write code once, but run this code multiple times for different tables. And when you're running this job for multiple times, you have the full choice to run in a sequence, run in parallel. That means a same job can run multiple times in parallel and also in a sequence. But the best part is that though you are able to run this job in the context of a table only. That means when you're running this job for customer, you're running this job only for the customer. Running for sales, running only for sales. Running for invoice, running only for invoice. No, okay. So though it is running for a particular table ingestion only, but you are not writing that code 3, 4 or 15 or 200 times. The code you are writing is only once, but you are able to run this job, rerun this job in sequence, in parallel, for these different tables to ingest your data. Okay, so this is more of a running concurrent jobs in order to ingest your data. Now this also comes with one key challenge which you have to be aware of, and that is your concurrency limitations. So if you look at the glue job, how many jobs can run in parallel or in a concurrent manners? At the account label, at the role label, there are certain limitations. So I'm not putting limitation here because that information, like, I mean, it's always, I always try to ask you to go and refer the latest glue limitation so that you always go and refer the latest thing. I don't want to put something here in print which becomes obsolete in a short span of time. But you should be aware that there are certain concurrency limit, like how many jobs you can run in parallel, and most of these limits are soft limit adjustable, so you can always put a request to increase the limit if your business requirement is like that. But the biggest challenge is that you have to manage your concurrency limit. But as long as you have managed that part, this is a good and fantastic approach where you're writing your code only once in a job, but then that job you can run to ingest multiple table data, either in a sequential manner or in a parallel manner or in a concurrent manner. So let's try to understand how this approach works. And it's a very simple one to do. That's why I said this is a very small video for this week. So how do you configure concurrent jobs? So first thing first, when you're trying to create a glue job, you have to configure maximum concurrency number. By default, maximum concurrency is only 1. So that means a job cannot run more than once in parallel. So when I'm running a job, if I want to run the job again, I have to finish that running first, previous running first, then only I can run. So first thing you have to do, go and increase the maximum concurrency. So for instance, here in example, if I'm putting my maximum concurrency as 4, that means this job can run 4 times in parallel. And 4 concurrent jobs can run. That means 4 tables of the data you can ingest in parallel. Okay. So that's first thing. It's one job configuration which you have to do, which is simply go and put a number over there. And of course, when you're putting number, I told you, beware of the job concurrency limitations quota to ensure that your number of concurrency is not existing the quota, otherwise job runs will fail. The second thing, you have to parameterize your code. Since you are writing your code only once, but you are using it for multiple tables, that means you have to pass certain parameter at the time of the run to make this job behave differently. So like in this example, I'm trying to, for instance, ingest data from RDS table to an S3 bucket. So the 2 parameters we are passing over here is table name and destination. And table name is the RDS table name, which I have cataloged, of course, in the glue. So it's a glue table name. And then destination is the S3 location. And all I'm saying here is that when I'm trying to read data from my table, I'm not hard coding my table name, but I'm getting it from my parameter. And then when I'm trying to write my data in S3 bucket, again, I'm not hard coding it. I'm reading it from my parameter of the job. So you create a job code like this, where your source table name and your destination S3 location both are parameterized. Of course, more things can be parameterized, but I'm giving this as an example over here. And that way, when I'm running this job multiple times, either in sequence or in parallel, all I have to do when I'm running this job, I simply change this table name and destination information to make this job do different tasks. So if I want to ingest customers table, I will provide customers table name and location for the customers. When I'm ingesting orders table, then I will put orders table name and destination, invoice table and destination, and that way I can run this job literally in parallel, same code in parallel, passing different parameters to be able to ingest data from different tables to the S3 bucket in parallel or in sequence if that's a requirement. Just change the parameter. So that's the second thing. You have to create a parameterized code. And third thing is pretty straightforward. You simply run your job, but since you are using parameters, you have to pass parameters when you're running the job, because your job depends on your parameters to come to know, to understand, to complete the business logic. So you have to pass parameter values when you're running the job. Now you can run job in multiple ways. You can run job from the console. In that case, you can provide this job parameters in the console, or you can run job using CLI. In this case, I'm showing example that this is my job name and this arguments I'm passing this table name and destination as an argument. And more importantly, generally you don't run job through CLI, or you don't run job through a console. Probably in dev and test you do, but not in when you're trying to use into production. In production, you generally try to create a workflow, and in a workflow, these jobs can be put into either parallel tracks, parallel execution I'm showing here in a step function, or you can create multiple workflows, which is simply using the same job but with different parameters to ingest the data. So you can run the job either from console or from CLI or from a workflow defined into step function or glue workflow, and in all three methods you can pass the parameters, specific parameter for that run, to let the same job do different type of data ingestion for you. So that's pretty much very straightforward. First, set max concurrency. Second, parameterize your code. And third, run your code with the run your job with the specific parameters passed. So what we are going to do, we are going to do a very small demo which will demonstrate the whole capability. So what we have done for that, we have got a PostgreSQL RDS database instance. And I'm going to I have configured a glue job which I'm going to run 2 times in parallel, and one job will simply take customers table and ingest into customer folder here, and other job will take employees table and ingest into employees folder over here. So this is a demo I'm going to show you to show the capability of running the parallel job or concurrent jobs. So let's see the demo. So here we go. So let me see if my Cloud Shell is running, because this is where I'm going to use to run my thing. Okay, so first thing first. So first thing first is my database. So this is my relational database. Nothing much to see over here. It's a Postgres database which has got 2 tables, customers and employees. Then what I have done is that I have created 2 tables over here. I have cataloged this. First I have cataloged these 2 RDS database tables. You can see here my table is cataloged, and it is creating a catalog table inside a Dojo database, and I have got customers and employees, 2 different tables. Then what I do is that I have created a glue job. And what this glue job does is that takes data from RDS tables and writes to this S3 bucket. So I have got this Dojo data set as the S3 bucket. And right now, if I refresh it, it shows only scripts folder, which is used for storing the script. But otherwise, I'm going to ingest customers and employees data into this particular bucket in customers and employees folder. So coming back to Glue console, so let's look into this job. So if you look at this job, if I go to details of let me edit the job. I don't want to edit it, but I want to show you certain areas. So here's my job. It's a typical job, nothing fancy here. So same job like you write every time. Only thing you have to do, you have to come to this section where you configure security, libraries, and job parameters, and there you have to set max concurrency. So by default, you can see the max concurrency is 1. But now you set, if you want to run this job in parallel, then you can set max. So max concurrency equal to 4 means 4 times in parallel this job can run in a concurrent manner, right? You can set any value more than 1. Actually, I think there's a limit. I have to see that. I don't remember, so I can't see any value. There should be some maximum limit, or maximum should be limited by glue limitation. I have to see that part. But yeah, you can set a number here depending on how many concurrent jobs you want to run in parallel. So that's the first thing you do. After that, so you set the concurrency setting. Then let's look at the code, and your code looks similar to any other code. Only thing is that this code is parameterized. You can see here that first I import all the libraries, and then I'm using this get resolve options method to parse my arguments or parameters pass. So job name is a standard parameter. You can fetch the job name, but here I'm interested in table name and destination. And then I create a glue context, and then I'm using glue context to read table data from my catalog. So you can see here, this is my database name. Well, I can also parameterize database name if you want, so that way it becomes even more reusable. But so far I kept database name hard coded over here, if you want to say, and then I am simply passing this table parameter value over here. So I'm not hard coding table parameter name, table name, but I'm getting it from parameter. So I have parameterized my code over here. Then I have put a sync location for the query. And then finally, I use the glue context to write data to the S3 location. And then you can see here in the format CSV. But then again, I'm not hard coding my destination location. I'm simply providing my destination location through the parameters. And that way, in this job, I can change my table name and destination location to make this job work for multiple types of ingestion. So that's pretty much how the code looks. So now let's look at, let's run this code. So you can see here I've tested it a couple of times. So if I refresh it, there's nothing running at this point of time. So what I'm going to do, I'm going to use, just to demonstrate parallel execution, I'm going to run this job 2 times in parallel with different parameters, and we'll see that this job will run in parallel, and then it will, when it completes, you will have data ingested to the S3 bucket in 2 different folders. So let me run the first job first times, and this time I'm using CLI to do that, just to demonstrate it. But I told you this you can do into workflows, whether you're writing workflow in a step function or in a glue workflow or in any other method. You can always pass the parameters to a job. So what I'm doing here is I'm doing AWS glue start job, my job name, this is my job name, and then I'm passing the arguments. And in this case, my argument is that my table is Postgres public customer, that's my catalog table name, and then my destination is Dojo dataset customers folder, in that like Dojo dataset bucket and customers folder. So let me run it once, and I should get a job ID back. Yeah, hopefully. Yeah, here we go. So that means job has started. And without wasting any more time, I'm going to run the second job as well. In the second job, everything remains the same. So same job name, but in this case, my table is employees and my folder location is employee. And I'm going to run this job again. So now my job has started running, and if I go and refresh, in fact, it automatically refreshed, you can see that this particular job, ingestion job, is running 2 times in parallel. So this job is running in parallel. And then very soon I should have this successful, and my data would have been written to the destination location. So let's wait till this job finishes the execution. Okay. So my job is finished. So if you look at my ingestion job over here and look at the execution history, you can see here these 2 jobs which are running now they are finished. They took respective 16 to 18 seconds of startup time, and then some 50 seconds to finish the job. Now so you can see that job run in parallel. I could have run 4 concurrent jobs, but I have just 2 tables, so I simply run 2 jobs in parallel over here. Then if I go to my S3 bucket over here, Dojo dataset, and if refresh my bucket over here, you can see that it has created 2 tables, customers and employees. And if I go over there, you can see the data created, and it is created in a partition manner, because I did not put any partition information, so simply using out-of-box partition over here. So the same goes for your employees table as well. So you can see here the job has done the job. Job has done the task of ingesting the data into the S3 bucket. So that was all for today, guys. I told you it's going to be a very small tutorial where you learn how and when you can use concurrent jobs to write code only once, but then ingest your data multiple times, either in sequence or in parallel by passing different parameters. So that's all for this video today. Hope you like the video, and if you like, please click on the like and please like button, and please subscribe to the channel. We always look forward to your feedback, whether it is for the new content or any mistake I have made which you want to correct, or if you have anything like any of the topic I have talked about and you want to discuss about it, and you have certain design things in mind you want to discuss, feel free to put that into comment. I look forward to your comment. I try to respond to your comment soon as possible. So I always look forward to your feedback to improve my content, to improve my presentation back to you. I promise to come back again in a week's time with another such tutorial. In the meantime, stay safe and have a nice day. Bye-bye.